I'm here with Koray Kubai from FLOX Robotics, and we're going to be doing a technical demo on how they capture images and then use Golioth to interact with AI services on the internet.
Today, I will show you how we use Golioth to handle our neural network model management on our edge devices. So for the demo today, I'll show you how we're using this Open MV RT1062 camera together with a NRF9160-DK for the demo. If you can see it here, there it is. So we're using the Open MV RT1062 MCU because it has great RAM size, so it's much larger than most other on the market right now, which means you can load large neural network model on it, and you also get pretty decent performance. I mean, it's so small, and we're getting pretty good FPS for our use cases anyway. For this demo, we're communicating over UART between the two boards using RPC calls to trigger the OpenMV card to snap an image, and then that image is then being transferred over UART to the NRF card, to this guy, and then that guy uses LTE-M and Koray protocol to then transfer the image up to Golioth. And then Golioth, we're using Golioth pipelines to then forward the image from Golioth to our S3 bucket. And then up there in our S3 buckets, we can just continue this way to collect a large data set. And then this data set can be used to retrain a new model for new classes, or just optimizing our existing model when we have our devices out in the field and we want to fine tune the models. So for this demo today, we will use hand signs. We'll collect some hand signs, and I mean, it's really important to have a good data set. So we'll actually be using the Hagrid data set, which is a great and vast and extensive data set for hand gestures. So we'll use that. But the overall procedure, by following these steps, you should be able to build up a pretty large data set over time without physical access to your edge devices, which is pretty neat, and which is the reason why FLOX is using Golioth for both their device management needs, but also for their neural network model needs. Let's start off. So here you can see some output, some stuff that needs to be cleaned up, but it works for this demo. So here, the NRF card is prompting us, is waiting for a button press or a manifest or an OTA update. And it's an OTA update we'll use. So when we have retrained our model, we would then upload it as an artifact to Golioth. And then using an OTA update, we would then transfer this TF Lite file in this case. So this neural network model will transfer that from Golioth as an OTA update to the NRF card, and then the NRF card would then transfer this TF Lite file over UART to the OpenMV card, and we'll have access to our neural network model there. So here we have the OpenMV IDE. We'll start the script, which is simply starting the RPC stuff that you have from OpenMV. So let's press a button. I'm making a thumbs up here. Okay, pressing the button. We're getting some stuff that needs to be cleaned up, but for the demo, this is fine. Okay, great. So we successfully uploaded the image. Let's have a look here. So let's go and have a look in our S3 bucket to see if we can find our image there. Yep, it's there. So let's have a look at it. Click here and download it. And there you go. That's me just a couple of seconds ago. So if we look at the Golioth console, what does that look like? So right now we were using our wildlife cam #1. And you can see here how we today, 30th of July, how we just transferred some images up until now. So this is some OTA stuff from before, but you can see the traffic going here. If we then look at our pipelines, you can see here how we just today, we transferred 52 kilobytes to our S3, to our Amazon S3 bucket. I mean, just think about what we just did. We just use a Sapphire-based application, which we know by using Golioth, we can do our firmware updates or OTA updates. We can do our device management needs. But now we also triggered it to snap an image, or we used it to trigger an image collection on an external device. We then transferred this image using LTE-M and Koray protocols up to Golioth, and then we sent it to the S3 bucket. And what does that mean? Well, just in the same way that we just looked at here in our S3 bucket, at this single image, we can keep doing this for a long time without needing to have physical access to our devices, and we can build up a pretty large data set specific for our needs. And then we can use this data set to train a new neural network, and then we'll show you later how we use OTA updates from using Golioth here to then send this newly trained neural network model to the edge device again. Okay, so I'll show you what we'll do for this demo. So we'll simply use a YOLO V8N CLS network, and we'll retrain it on the Hagrid dataset. It's a pre-existing dataset. I didn't collect this. It's a really good dataset consisting of different hand gestures. So you can see here how we're loading the YOLO V8N CLS network, and then we're retraining it for 100 epochs. What's actually important here when you're working with microcontrollers is to do the integer quantization of your model, because as we all know, they have limited RAM, and well, using float numbers for all of these weights, well, that's gonna take up a lot of RAM. So you need to transform, or you need to convert all these float values into integer. What we have done is that we train the model and then we export it into TF-Lite format. And this TF-Lite format, we now want to get back to our edge device without actually having any physical access to it. And then we'll use, guess what, Golioth. So we'll upload this TF-Lite file to Golioth, and we'll use an OTA update to get it over there. Okay, so now it's time to get that new TF-Lite file, to get that new neural network that we designed, the new model. We need to get that onto our edge device without physical access. And as I mentioned, this is where Golioth comes into play again. So not only are we using Golioth for our device management needs here at FLOX, we're also using Golioth for our neural network model management too. So you can see here in our artifacts, in the same way as you would do OTA for the firmware of your app, we're handling our different models. So here we have different versions of our YOLO model here, the YOLO neural network. So how do we get this file up then? Or to our edge device. So what we do is we create a new artifact. We select the existing blueprint. We tell, you can be more precise here, but for the demo, this is fine. We're saying that we want to update our YOLO model, and we'll give it a new version, let's say 0.06. Then we upload the artifact. So in this case, that will be the TF-Lite file. So let's see. So we'll find it here. Just bear with me here. We'll just get the correct TF-Lite file. So here we go. Okay. All right. So usually I would, so what you do is you zip your labels together with your neural network or your TF-Lite file here. So that would be this then. And then and then we create a release just like a regular OTA updates. So let's cancel this rollouts. So we create a new one. Again, select that, select the beta, and we want to have the correct tags for this, for our wildlife cam. And let's say we pick the newest artifact, and that's it. And then we create a release. And here it is. And then we do a rollout. So we have now performed the rollout, and we have now transferred our neural network model to the NRF board. So instead of doing a firmware transfer for the OTA update, we have transferred a neural network model, and we're updating our neural network model. So it's transferred to the NRF board, which is our communication MCU. Okay. So now that we have received the TF-Lite file, the new neural network model, through the OTA update with Golioth, it's time to try it out. So we'll use the Open MV IDE for this, just to visualize what we're seeing. So we can just quickly take a look at the script here, what we're doing. So we're loading our this new TF-Lite file that we just transferred using the OTA update. And then we're running inference on the images that we're taking with the Open MV card. So remember, this new TF-Lite file, this new model is running on the Open MV card. So it's a microcontroller which is running the YOLO V8 and CLS network. So don't expect too high FPS, but it's pretty impressive that we can run this today. I mean, it's things are moving forward pretty fast, so it's cool that we can do this. All right, so let's give it a shot. Let's see what this new neural network model looks like. What's the output? Okay, so there I am. All right, so here we go. Now it's running inference, so we're not doing anything, but what happens if we do this? Confidence goes up. Okay, that's a like. All right, makes sense. You can see down here how the FPS is around 0.6. Let's see if we can make this bigger. Yeah, you can see around 0.6 on YOLO V8. Okay, how about this now? All right. So dislike. Okay, good. All right. And that's what it is. Okay. How about this? Let's see. Yep. There you go. That's correct. And last one. Yep, that's correct. All right, let's stop this. So, all right, let's just think for a moment what we have done here. Like what has actually happened. So we started off, we have our Open MV cam connected to our NRF9160-DK board, connected over UART. And then the NRF board triggered the Open MV RT1062 cam or MCU to take a snapshot, to snap an image. And then this image was transferred over UART to the NRF card. And then by using and leveraging Golioth, we could use over LTE-M and CoAP, by using CoAP protocols over LTE-M, we could then blockwise transfer this image up to Golioth. And then by using these pipelines here, we could then forward this image from Golioth to our S3 bucket. And then what can happen there is that you can then build up this large data set with your edge devices with no physical access. They can be in hard to get areas, and they can be anywhere. You don't even need physical access to start collecting data sets. So imagine you have several of your edge devices out, and that's at FLOX we have our devices out in the forest. They need to find the actual animals, which we need to deter, right? So this way we can collect large data sets by leveraging Golioth and with our edge devices. So then we can collect this data set, and for this demo we use the Hager data set, but it's in the end you can collect a large data set, as I mentioned, and then you retrain your data set, you retrain your neural network model with this new data set that you have gathered. And then when you have a significant and pretty good data set, you can retain your neural network. You can do the integer quantization of your model such that it can be loaded and run on your edge devices, on your microcontrollers with limited RAM. But okay, now we have this new TF-Lite, but how do we get it back on the edge devices? Well, we use Golioth again, of course. So not only are we using Golioth for our device management needs, but also for our neural network model management. So we then, as I mentioned, by using the OTA updates, we can also not only transfer firmware updates for our MCUs, but we can also transfer our new updated neural networks. So we transfer this by using the OTA updates and CoAP blockwise transfer again. We sent our TF-Lite file down to our NRF board using an OTA update. And then from the communication MCUs to the NRF board, we transferred this new TF-Lite file over UART to our Open MV card, and we ran inference locally on the edge device by using the awesome Open MV RT1062 MCU, and we could get pretty neat, pretty cool performance on the small Open MV cam. And that's basically how we at FLOX leverage and use Golioth for our not only our device management needs, but also for our neural network management needs. That's it for me. Thanks, guys.